Okay, so now we're going to look at line balancing, okay? So before, we already have the line there. You have the workstations, and then we were just looking at the time and understanding who was the bottleneck, how much to produce, what is the throughput time, blah, blah, blah. Now we're going to get in depth into the process steps. Right? So we're going to break down those activity into smaller steps and say how many people do I need to have on that line. So how many process steps I'm going to have, how many workstations I'm going to have. So imagine that you're working for, let's say, Starbucks or Chick-fil-A or Subway, and you have to determine, okay, how many people you need and who's going to do what. So it's before looking at the process as it is. That's what we did before. Now we're going to build it. We're going to design it and say how many people we need and who's going to do what. Okay. And that's called managing the line process. Okay. And a line will be, workstations that are one after the other, like a subway process, right? You have one step and then you have the other step. And you have some concept called the precedence diagram here that we're going to learn about, and we're going to use it again in chapter number 7, so it's going to stick with us a little bit, and just showing the immediate predecessor. Okay, so let's look at this example and follow this example. We have Greengrass that manufactures lawn and garden equipment. They're designing their assembly line for fertilizer, the big broadcaster. And we have this information. So we have the information of the steps. We have the information of the description. We don't know how many workstation or how many process steps are going to have. That's what we need to find out and answer. So we have the work element A to I. We have the description of the step. We have the time that it takes, and you have the immediate predecessor, right? And immediate predecessor is like the requirement, right? For example, when you're registering for a course, some courses have requirements, right? So before you do 395, which is this course, you have to do 290 and 291, I think, or I hope. So that's management science, all of them, right? So that's kind of guarantees that that you're ready to that course, right? So that's going to call that immediate predecessor. So to do my next class that I teach 485, you need to do this one, which is 495. So here we have the predecessor. So step A can be done immediately, but to do step B, I have to do A first. To do C, I have to do A first. To do D, I have to do B first. Okay? And then we can take this information and draw a diagram that shows the relationship between them activities and their immediate predecessors. We also have the time. So the total time is going to be 244. Just sum all the time of all the process steps. And this is the diagram, and you guys need to learn how to do that because we need it from here and we need it for project management as well. So remember, process A, you can start immediately. To start C, you need to have A as a predecessor. To start B, we need A as a predecessor. To start D, we need B as a predecessor. To start E, we need B. To start H, we need D and E. And that's the information, coming from this table here, the immediate predecessor, okay? And then you can draw this, and here we have the time. So we know the elements, we know the time, we don't know how many people we need. So one person can do all this, but maybe we need 2, maybe we need 3, maybe we need 8 people, each one doing one little step, right? We don't know yet because every step has a different time. And what we want is to balance this time, to have less kind of difference between the process steps, right? So first concept is what we call the desired output. So that's the number of units per time. And the way to calculate this is desired output, let's say per day, divided by the time available in a day. So the problems can differ if it's a day, a week, or a month, but you always have to have the same unit of analysis here. And the cycle time will be 1 divided by that desired output rate, okay? So let's say that, you have the output is going to be 200 units and I have 400 minutes in a day, right? So if I take 200 and divide by 400, it's going to be 2 units per minute. right? And if I put that into this formula, 1 divided by 2 is going to be half. So half minutes per unit, right? So every 30 seconds, basically, which is half a minute, I need a unit. And that's what's called cycle time. Okay, cycle time is 1 divided by the output rate.